Okay, so the complex number U is is defined by this, where A is a positive integer. Express U in terms of A in the form of x plus iota y. All right, so we will need to rationalize this for part A. So under root 2 minus A under root 2 iota upon 1 plus 2 iota times 1 minus 2 iota upon 1 minus 2 iota. All right. Now the denominator becomes a squared minus b squared. So 1 squared minus 2 iota whole squared. So 1 minus 4. So that's a 5. Do show the working for this on the side. So equals 5. Okay. Now multiply the numerators under root 2 minus 2 under root 2 iota minus a under root 2 iota, and then we get a minus minus plus, but iota square becomes a negative 1 again, so we get a negative 2a under root 2. Okay, now we're going to split the real and imaginary part, so we get under root 2 minus 2a under root 2 divided by 5 and plus minus 2 under root 2 iota. In fact, let's take iota common. So minus 2 under root 2 and minus a under root 2. In fact, we can also take under root 2 common in both of them. So under root 2 common. We get 1 minus 2a upon 5 minus under root 2 common 2 plus a iota over 5. This should be the answer in proper x plus iota y form. Okay, so the first part is done. Second part says part B, it is now given that a is equals to 3. So let's just first replace a with 3. So when a is equals to 3, then u becomes, this is also u. Replace the 2 with 3, so we get 1 minus 6, which is a negative 5. So we get a minus under root 2. And then replace the second a with 3. So we get 3 plus 2, 5. 5 divided by 5 is 1. So again, minus under root 2 iota. Okay, this is the simplified u. And now we have to express this in REI theta form, that is polar form. So for polar form, let's plot it. X value is negative under root 2, y value is negative under root 2, and we find this r is equals to square root of 2 whole square plus square root of 2 whole square. Basically, we've applied Pythagoras theorem on it. So r equals 2 plus under root 4, which is 2. So r comes out to be 2. And for the argument, we need this angle. It will be a negative angle. Before that, we'll find this theta and subtract it from pi and write our angle, but with a negative sign. So tan theta would be equals to y over x. So y is under root 2 and x is under root 2. We ignore the signs for this one. So tan inverse 1 would be pi by 4. Then pi minus pi by 4 would be 3 pi by 4, but with a negative sign. So the argument would be negative 3 pi by 4. So write it in proper polar form. 2 e minus 3 pi by 4 iota and equals to u. All right. Part B is done. Part C, find, using your answer to part B, find the two square roots of u. All right, so we're already in polar form. We should be able to find the first square root pretty easily. Okay, so the first root is, u is equals to 2e minus 3 pi by 4 iota. Okay, we need its first square root. For square root, we take power half. That means we square root the r or take power half on the r. So square root of 2 or 2 power half. And you multiply this half with the theta. So minus 3 by 8 pi iota. This is the first root. And they want the root in the form of polar form r e j theta I theta. So this is the first square root. Now, how do you find the second square root? If we just randomly plot any square root, then the second square root is actually the same root multiplied with -1. So if this is a plus iota b and we multiply it with -1, it becomes negative a and negative iota b. So it falls in the third quadrant. We'll have negative a here and negative b here. This was a and b. So when we're finding the square root, if you have one root, you can find the other root by multiplying the first root with -1. So we see that it falls on the in the opposite quadrant. If it was in first quadrant, the other square root is going to fall in the third quadrant. We see that that's a shift of pi. And we see that nothing happens to the modulus of these roots. If this is the modulus of the first root, the modulus of the second square root is also going to be the same. So the second square root would be u, or just let's just write the answer, or u half equal, let's call this 1, let's call this 2, would be the modulus of the other square root stays the same, but the angle gets added with pi. So add pi to the angle, which gives, when we add pi to it, we get 5 by 8. So the second square root of u will have the same modulus as the first square root of u, but its argument is going to be plus pi more, so 5 by 8 iota. 5 by 8 pi iota. This is the second square root.